So now let's look at some explanation. Some explanation. Let's say explanation to some effect of refraction. How refraction can be used to give explanation to some phenomenon, refraction, okay? And we are going to begin with the appearance of the sun when setting from the west. Okay? So we are going to look at the appearance of the sun when setting to the west. Okay? I think that would be the English. When setting to the west. So I can have here some simple illustration. If this is my earth, okay, and then I know I will have number of horizons, I mean the numbers of layers, I can represent this few, and now this one is our horizon. Okay, now if the sun has now set, it has gone below the horizon, that means that it is in a position that we are not even supposed to see. But you realize that for us, we shall still see it. What happened is, the rays from the sun will come there. Because now the truth is, as the sun is setting, what is very true is that the layers of air that is next to the earth's surface becomes very cool, isn't it? Late in the evening, the air becomes cool, and if it becomes cool, what is very true is that it becomes more dense. Okay, it becomes more dense than the one above. And now, if light rays is moving from less dense to more dense, refraction is toward the normal. Okay? So, if this ray now comes, maybe say is incident to the first layer here, if it is incident here, this is my normal, it will be refracted towards the normal. Isn't it? It will be refracted towards the normal. Again, if it meets this layer here, it will also be refracted towards the normal. And now, if an observer is here, this is the position of the observer on the Earth's surface, we'll see this light as not refracted, but we'll see it coming from here, and we'll see the sun as above the horizon. This is image of the sun that we always see and say the sun has not yet what? Set. But the sun has already gone below. We are just seeing the image. The image you are seeing it because of refraction, that the light rays, that is, these layers which are very close are more dense. These ones are more dense and these ones are less dense. So therefore, moving from less dense to more dense, refraction happens towards the normal. We talked about like this, that if this is air and this is glass, light rays which comes here towards the normal is this side, because this is the line that divides. This is away, this is towards it, so it will bend toward from more less dense to more dense. So what happens is, when the sun is setting, we can even be writing here, when the sun is setting, comma, the air layers close to the earth cools down and become more dense than those layers higher or away, far away from the Earth's surface. Okay? That when the sun is setting, the air layers next to the Earth's surface, they cool down. And when air layers cool down, they become less dense. They become more dense. Okay? Setting, the air close to the Earth's surface cools down and they become more dense than those layers higher or far away from the Earth's surface. And then we can say for light rays propagating from less dense medium to more dense medium, comma, they are refracted towards the normal, and therefore the rays from the sun are also refracted towards the Earth's surface continuously. Okay? So light rays moving from less dense to more dense are refracted towards the normal, and for the light rays from the sun, therefore, will also be instead refracted towards the Earth continuously, toward the Earth's surface continuously. And then you say, to an observer on the Earth's surface sees the sun as being above the horizon. Okay? So, for the person who is here, instead will see the sun as coming from here, because the result of the refraction is the bending will not be seen by this person. This was coming from here. For him will receive this and will see as if it is coming from the other side. Hence, seeing that the sun is still up, okay, is not now below the horizon where he cannot see. So he gets an impression that the sun has not yet set. But in real sense, the sun has gone below. But because of the refraction, that if this layer is more dense, that means that if this light rays comes, instead of moving the other side, it comes this other side, isn't it? Towards the normal. Also, when it comes here, because this one is more dense than this, instead of going maybe up, it still comes this other side. So continuously it will reach the person on the earth. And now to this person here will not see this light in a bending format. Will say instead see everything instead, like then he will see the sun here. And I will say the sun has not yet set. But in the real sense, the sun is now below a point you can't see, but because of refraction, that's why we are seeing it here. And what is very true is that the same scenario is also true for rising sun. So it is also true that we can see the sun even before it comes out, you start seeing it. It is also because of refraction. In the morning you may look at the sun and say the sun has risen up, but in real sense that is just the image. It is because also early in the morning it is too cold, the air close to the earth's surface is too close than the one up. Therefore the sun, when it is below even a point where you cannot see it, what happens is rays from it will come, will be refracted towards the normal. Find another layer will also be refracted. Now for you to see the sun is here, has already moved out, but in reality the sun is still down, but refraction is the one that is bringing it up, and now you see the image of the sun to look like it has already risen. So if they ask you to explain this scenario, it is for both setting and rising, okay? So it can also apply to that. So that is one of our explanation of some effects of refraction. So it is refraction that makes us see the sun before rising, and it is refraction that makes us see the sun even after setting. It has already gone, but we still see it. So the image is the one that we see as a result of continuous refraction towards the earth. So let's meet in the next episode that is bringing to us another effect of refraction.